So square root notes. On the top of your note sheet, the first bulleted point says on your sheet, the square root of a number is a number that, then you have the dot, dot, dot. I want you guys to write in, multiplies by itself to get the radicand. So I want you to write what I'm underlining here in red. The words that are in parentheses, you don't have to write down, it just further explains it. Basically what that means, it multiplies by itself, a number that you can square. Now, when I say multiplies by itself to get the radicand, that's a new term. We haven't talked about radicands before. So when you have a square root, I would recommend putting this up on the upper right-hand corner of your paper. So when you have a square root, this sign here is our square root sign. The number inside of the square root, that's your radicand. So the number inside of the square root, that's your radicand. When we get into simplifying square roots, you are going to need to know what your radicand is. So you'll need to know what that term means. So we're talking about the square root of 16. If I want you to tell me what the square root of 16, don't use your calculator, but think, what number can you square it to get the number 16? Okay, so if we take 4 times 4, we're going to get 16. 4 times 4 would be called standard form, except we're not using prime numbers here. If I wanted an exponential form, it would just be 4 squared, right? So 4 squared would equal 16. That's what it means by a number if you square it by itself. Okay, so we're talking about squares and square roots. We all have this down? All right. Now, the next part on your sheet, it's asking you for the first 12 perfect squares. So what that basically is asking of you guys to do is to go through and list the first 12 perfect squares. So how I would recommend that you do this is by writing out the number with the squared and then the answer below it. So if you're writing out the first 12 perfect squares, it's asking you, what's 1 squared going to be? 1. Okay. What's 2 squared going to equal? What's 3 squared going to equal?
6.
No. 9.
What?
It's not 3 times 2. It's 3 times itself. What's 4 squared going to equal?
16.
5 squared.
25. You put 6.
6 squared going to equal?
36.
Okay, do you see how I'm making this list? So I want the first 12 perfect squares. So after 6 squared will be
7 squared.
7 squared, which would equal,
49.
after 7 squared would be
8 squared.
8 squared, which would equal,
64.
then we have 9 squared, which would equal 10 squared,
100.
11 squared,
I think 121.
you're correct, and 12 squared.
144.
Okay? So these are all going to be very important information that you have. So we have the first 12 perfect squares. So if I would ask you, what is the square root of 9? What's your answer? 3. What's the square root of 144? 12. Okay? Do we all have them down?
No.
Okay, I'll give you just a second. While people are finishing up writing down the first 12 perfect squares, if you use your multiplication chart, especially the big jumbo one I gave you guys, what do you notice that goes right down the middle of it? Like catty corners and bold. They're not prime numbers. Those are all. So look at our perfect squares. 1, 4, 9, 16, 36, 49, 64, 81. What? Somebody said it. Yeah, they're all perfect squares. So what's the square root of 30?
900.
Or sorry, what's 30 squared?
No.
So what's the square root of 900?
30.
30. So squares and square roots, do they ever end? No, they're infinite. Just like numbers. They go on and on and on. All right, let's look at, we talked about that. Let's look at our first example problem now. I am going to make you show me extra work for now. I know, right? Oh, God. But the reason why I'm having you do it now, when we get into the next week's lesson and the week after that, it is going to be so important that you understand the concept of what I'm trying to teach you. So although it's easy to write just the square root of 64 is what? 8. I'm going to make you show me an extra step before you just put 8. Okay? So what number can you square to get 64? 8. So how you're going to write your answer? You're going to come to the right of the square root of 64. You're going to put an equal sign. You're going to put a square root sign. And you're going to put your 8. And you said 8 squared gets me to 64? So you're going to put your squared sign underneath the square root bar. Now, you guys told me inverse operation of addition is subtraction, multiplication is division, and square root is square. Or square is square root. So what happens with this square and square root bar? Yeah, they just cancel out. So we draw a little line through both to show that they cancel. So once they cancel, then we can just write our final answer, 8. I understand it is an extra step right now, but it will make sense when we get into simplifying square roots that are not perfect squares. All right, let's take a look at example number 2. So you have the square root of 4. What is the square root of 4? 2. So how we're going to write it equals the square root of 2. So 2 squared equals 4. So we're going to write it square root 2 squared. Make sure that squared is underneath your square root sign. And what happens to square and square root? They cancel out. So it just equals the 2. So basically, by canceling the square and the square root sign out, you're just left with the number inside. The radicand becomes the coefficient. Throwing a new word at you, right? Because the radicand is the number inside of the square root sign. Well, if that cancels, you're left with just a number, coefficient. All right, let's look at 3. I'm going to mix it up on you guys in just a minute, so don't think you're pros at this. You think you're good at this now? Just wait, I'm going to throw you a curveball in a moment. So the square root of 144 equals, so how do I write this? Square root of 12 squared. Cancel my square root and square, and it equals just a 12. Okay, let's take a look at example number 4. What is the square root of 1? 1. So again, we're going to write the square root of 1. If we square it, the square and square root cancel, and it just equals the number 1. It's just a front side of notes. All right, we good? Let's take a look at example number 5. Okay. This is written differently. So we have the square root of 5 squared. What do I do here? Darius?
Don't you got?
You cross it out.
Yeah. Because what cancels? Square root and square, they cancel each other out. So what am I just left with here? Just with the 5. That's it. That's easy enough, right?
Was this a curveball?
Curveball, what?
I'm going to make it harder. Trust me.
See?
Are you up for this challenge?
Yes.
She may give us a doubt. Look.
Ah!
Cross out the.
Okay, so what am I going to do here? Okay, so I'm going to cross out both of the 2's just like this.
No, you gotta cross over the top of it.
I have to cross them out with the square root signs. So that cancels that square root. This square cancels that square root. So then what am I left with?
35.
So I'm left with 5 times 7, which then equals 35. Until I give you the worksheet and the last 5 questions on your worksheet, you're like, wait, I do want to show you one.
What worksheet?
If I were you on your sheet, listen to me. If I were you on your note sheet here, I would put example number 7. I would put example number 7. So example number 7, you have the square root of 9 times 4. So there's 2 ways that you can solve it. I feel that there's an easier way to solve it, but we'll see what you guys come up with before I help you out. So you have the square root of 9 times 4. Do I have squares here? So can I just cancel the square root bar out of there? No. So I first need to simplify under the square root. So simplify just means solve. So what's 9 times 4? But it's still under the square root bar, right? Because we haven't gotten rid of it. So now we have to get rid of the square root bar. So what's the square root of 36?
6.
So this is where we do our 6 squared, square root, cancel to just get 6.
Then we done.
And then you're done. All right, any questions?